Okay, the preamble to the Unit 10 is reviewing some formulas and concepts that you've seen in middle school that need a little bit of review. So we should be able to go through this pretty quickly. The perimeter means the measure around. So perimeter of a polygon is what you get when you add up all the sides, the distance around a polygon. You don't really need a formula for the perimeter of a polygon. You just need to be able to add the sides. So let's take a quick look at the long way and the short way to do each of these. So if I want to find the perimeter of this first rectangle, I could find the measures of all four sides. So opposite sides are the same. So we have a 9 centimeter and a 5 centimeter side that's unlabeled that we need to take a look at. And then we can just add all the sides. 5 plus 9 plus 5 plus 9. That's the long way. It's shorter if you do some condensing down parts. So there are 2 9s, 2 times 9, and there are 2 5s. If we add the 2 times 5, then that's going to get us there a little bit faster than writing down 4 different terms to add. So perimeter equals 2 times 9 plus 2 times 5, which is 18, plus 10, or 28, in this case, centimeters. Now this is centimeters, not squared. This is just centimeters because it's a linear measurement. Technically, if you wrap a string around this rectangle and then you break it apart at a corner, you could pull that rectangle apart and lay the string out flat and make it just a line. So it's never going to be square units. It's always going to be linear units, centimeters to the first power. Okay. Again, if you want to add the parts 5 plus 9 plus 5 plus 9, that still works. Okay, the next one is a square. Well, it's a rhombus. We do know it's a rhombus because all four sides are equal. Not sure about the angles, but it doesn't really matter. So we could label all the sides 7 centimeters and add 7 plus 7 plus 7 plus 7. Of course, there's a shortcut. For squares or rhombuses, in this case, you have 4 of the same side. So we could do 4 times 7 centimeters, which is 28 centimeters. So that one has a perimeter of 28 centimeters. Take the shortcut if you know how to use it. And last but not least, we have this irregular figure. So there's a long way and a short way, and we'll look at both of them. The long way is to find all the individual lengths and then add them up. So we've got a couple of lengths missing. We have 4 up the left side, which means the right side should be 4. We're going to assume that all angles that appear to be right angles are. The instructions that came with this question actually said that. I just cut and pasted it from a different document and didn't carry the instructions with it. Okay, if we have 2 inches or 2 units long here, that means we should have 2 on this sort of a mirror image of it over here. That's 2. And then we have this horizontal segment that's unlabeled. All the way across from left to right should be 7. If this piece is 2 and this piece is 2, that's 4. That means there's 3 units left for this unlabeled part, so this should be 3. Then you can add all your pieces together. So 4 plus 7 plus 4 plus 2 plus 2 plus 3 plus 2 plus 2. I would start at any one side and go around in a circle to make sure that I don't leave any out. When we add all that up, we get 11, 15, 17, 19, 22, 24, 26. Did I add something goofy? Nope, that's right. I get 26 for a total. 26 units. I don't know what the units are, so I'm just going to call them units. Okay. Now, I said there was a shortcut. So I don't know that it's really that much shorter, but it's a thought. Okay, so you have 4 up this side, 4 up this side, 7 across the top, 7 across the bottom. You can picture moving that 3 down to here. So you could do 4 times 2 plus 7 times 2 to get most of your sum. That would be 22. But then you have these two extra pieces here and here that would have to add to that to make 24, 26. If you can see that and you find that easier, then by all means use that shortcut. If that's a little bit hard to follow, don't worry about it. Just add up all the sides. It's the safest thing to do. Okay, occasionally we get a problem that's in the coordinate plane. So let's take a look at one of those. We have a polygon with 3 vertices that are given, and we want to find the perimeter. So let's do a graph first. We always want to see a picture first. So 1, 2, so over 1 up 2, that's R. 1, -2, so over 1 down 2, that's S. And then 4, -2, so over 1, 2, 3, 4, down 2, that's T. And it says those are the vertices of a polygon, so those are the corners of a triangle. So sketching your triangle. And we want to know the perimeter, which is the sum of the sides. So let's figure out how long the sides are. We can count to get 2 of them. Horizontal and vertical sides are easy to measure. We just count spaces. So on the bottom between S and T we have 1, 2, 3 for that length. So 3 plus, up the left side we have 1, 2, 3, 4 units long. So plus 4 plus, now here's the tricky thing. Diagonal measurements, you can't count squares to get. The only way to get those is either with a distance formula or with Pythagorean theorem. This is a right triangle. I could do 3 squared plus 4 squared equals x squared, find that missing side, and then add it on. Fortunately, this is a triple that we should have memorized by now. 3, 4, 5 is a Pythagorean triple. So add the 5 for the third side, and 3 plus 4 plus 5 is 12 units for the perimeter. If you don't have your triples memorized yet, it is time to get that done. Okay, one more set of formulas. Circles. You have seen circumference of a circle before. This is not new stuff. There are actually 2 different formulas. There's the formula that says that circumference, C, equals pi times diameter, and there's a formula that says that circumference is 2 times pi times the radius. What I find is that students typically get the 2 pi r for the circumference mixed up with the pi r squared used for area. So we're going to take the safe route and use pi times diameter. It's faster, and it doesn't confuse with the area formula nearly as easily. So pi times diameter, let's see. C equals pi times the diameter. Okay, diameter is the distance across the circle going through the center. We know a radius is 12.5. If we keep going the rest of the way across the circle, 12.5 plus another 12.5 is 25. So the diameter is 25. So pi times 25 units. There's 2 different ways to finish it. One is to leave your answer in terms of pi, in which case you just move the pi to the right like you would a variable and call this 25 pi with an understood multiplication between them units. Okay, and on standardized tests like the ACT, this is typically the way your answer choices are going to be written. So it's less work that way. That's good, and you don't need a calculator to do it. That's good as well. So this is your answer if you're told to leave it in terms of pi. It means the pi is still there. You didn't multiply by it. If you need a decimal form, and sometimes you do, then you do a decimal approximation. You could either use 3.14 as an estimate, or you have this really cool key on your calculator that knows pi to way more decimal places than just 2. So that pi key is down at the bottom, right beside the H. If you press that key, you'll get a menu that has pi in it that you can paste in. Okay, so we want to know what pi times 25 is. So pi key, press enter to paste it in, times 25 equals 25 pi. Oh, well, we already knew that, didn't we? We need a decimal, so control enter for me, which is just enter for you. You have a different calculator than I do. That's about 78.54 if you do a couple of decimal places. So 78.54 units would be your decimal form. So that's, or one or the other, that's your decimal approximation. We'll just abbreviate that. Depending on what you're needing the result for, sometimes a decimal is better, sometimes pi form is better. We need to practice both. But guaranteed you'll do pi form on the ACT. It's going to be that way. Okay, let's do one more. We have another circle with a diameter of 11. So circumference equals pi times the diameter of 11, which is just 11 pi feet. Done. It is that easy. There's no calculation to do at all. You can get a decimal form if you need it, but there's no reason to force it, so we're going to move on. That leaves us with this last little piece of information, which is what happens if you just want a piece of the circle. What if instead of walking all the way around the circular track, you only walk a third of the way around? Then how do you find that distance? So that's called an arc length. A piece of a circle is called an arc. How long that piece is called the arc length. This piece of pi that is drawn in this circle here is called a sector. So we want to know the arc length of this arc that's on the outside edge of this section of the circle. There's a formula for that. If you look closely, you'll notice that the last part of the formula is pi times diameter. It's the circumference. The only difference is you have to take that circumference and multiply it by the fractional part of the circle that you have. And so the n over 360 is the fractional part of the circle that's given. So let's apply this formula. There's not really a letter for arc length that makes sense. When we do arc length in trigonometry, we normally call it S. I don't know why. We just do. But I found that more confusing than just using the word arc length. So we'll just use the word arc length. So I need the length of this arc. It's darkened in, but it's a little bit hard to tell. I want to know how long that piece of the circle is. So the arc length is equal to how many degrees are in that arc, which is 120 degrees, out of 360. The whole circle has 360 degrees in it, so 120 over 360 is actually 1/3 of the circle. A third of the circle is highlighted. And then we multiply by the circumference, which is pi times the diameter. Well, the radius is 9, so the diameter all the way across would be 18 inches. Diameter of 18. Let's leave it in terms of pi, which means when we do the computation, we only want to do the fraction times 18. So let's get a fraction template to start with. Control divide will give you a fraction. 120 over 360 matches what's on paper. Now, we need the cursor to move out of the denominator on the screen, so we're going to just click on this right arrow one time, and it's going to move the cursor to the right of the fraction. We're going to skip over the pi and then do times 18. So we're going to multiply everything except the pi. So it turns out that 1/3 times 18 is 6. So this is 6, and then bring down the pi. 6 pi inches is the arc length. If we needed a decimal form, and I'm not going to actually put it on paper, but we could, when we type it in, instead of skipping over the pi, we could say times pi times 18, make it look just the way it does on paper, and the calculator will give us a decimal approximation of about 18.8 inches. Alright, let's practice one more of these and we'll be done. So this time it's a little bit hard to tell, but the darkened in sector is this section right here. So this is what we're looking for. It's a little easier to see before I printed it out, but I want to know how long that is. I have a formula for that. It says the arc length is equal to n over 360. Okay, n is the angle in the sector that makes that arc. Oh, well, let's see. It's not labeled on this one. Now what will I do? Well, it turns out that 18 is a diameter, which means this whole arc that I'm drawing on here, from one end of the diameter around to the other end of the diameter, is half of the circle. If a circle has 360 degrees in it, then half of that is 180, which means these two pieces of arcs have to add up to 180, half the circle. 180 minus the 30 that's already labeled means 150 left for the other piece. So the two pieces of arcs have to add up to 180 degrees. So the arc we're looking for has an angle measure, or an arc measure we sometimes say, of 150 degrees. So 150 over 360 times pi times diameter. The diameter in this case is 18. Okay, let's do it in terms of pi. So control fraction. 150 over 360 times 18 is 15 halves. Scoot that over a little. So this is equal to 15 halves pi. Or you could write it as 15 pi over 2. It's okay to put the pi in the numerator with the 15 if you prefer. A lot of times that's the way it'll appear in your multiple choice answers. So pi at the end or pi at the top, they mean the same thing. And these are feet, so feet. So 15 halves pi feet is your arc length. If you want a decimal approximation, type in this original expression just the way it looks, including the pi, in the calculator, and then round to an appropriate decimal place. Okay, do some practice, and more to come later.